Hello everyone, it's a pleasure meeting you all in my mathematics class again. Today my topic of discussion is exponential distribution. This exponential distribution is a continuous distribution. It is continuous distribution. We define this exponential distribution as follows. It is a random variable. If it follows the exponential distribution, its probability density function is given. Its probability density function. The probability density function is given by fx of x is equal to lambda into e to the power of minus lambda x to the power of x greater than 0. In other places it is 0. In the sense, this function or the exponential distribution is defined only for values x which is greater than 0 up to infinity, and that lambda is a parameter of the exponential distribution. So this is how we define the exponential distribution. Now let us, as I told you, this is a continuous random variable because it takes values, all the values from x is equal to 0 to x is equal to infinity. Okay. Now let us now find what is the mean and the variance of the exponential distribution. Now this you can do it in two ways. That is, you can find the moment generating function, and also you can do by using the method like this. You can use e of x is equal to, it is 0 to infinity x into fx of x into dx. And likewise you can find e of x squared, and e of x squared is equal to 0 to infinity x squared fx of x into dx, and sigma of x squared is equal to e of x squared minus e of x whole square. So you can use this method. E of x is equal to x into fx of x dx, integral ranging from 0 to infinity. It is 0 to infinity. And find e of x squared and use the formula e of x squared minus e of x whole squared. You will get the very same value here, 1 by lambda and 1 by lambda squared. But I have chosen using the moment generating function, and the moment generating function mx of t is given as exponential e of e to the power of tx, and this is called the moment generating function, and this x is now what I have taken is the random variable that follows the exponential distribution. Now therefore mx of t is given by 0 to infinity, because this distribution is defined in the interval 0 to infinity. Therefore 0 to infinity of e to the power of tx into the probability density function of this. So that is equal to lambda into this. This is a very simple integration. You will get like this, and you apply 0 to infinity, you will get lambda by lambda minus t. That is, the moment generated function value is lambda divided by lambda minus t. Now to find the mean of x, it is enough that you find the first derivative of the moment generating function and take t is equal to 0. That is m dash of x t, that's m dash of x of t is nothing but d by dt of this. Now lambda can be taken outside. You take the differentiation of this. When you take the differentiation of this, you get and apply t is equal to 0. You see that it comes 1 by lambda. Therefore e of x is equal to 1 by lambda. Now to find what is variance? The variance of the exponential distribution is e of x squared minus e of x whole square. Now let us try that. This e of x has already been found to be 1 by lambda. So it is enough that you substitute the value here. But we have to find the second moment. This is nothing but your second moment of the exponential distribution. Let us find the value of this e of x squared. Again the second moment is determined by taking the second derivative of the moment generating function and take t is equal to 0, you get the second moment. And the second moment, now this is equal to m w dash of x t, and we take t is equal to 0. that is d squared by dt squared into of d squared by dt squared of lambda by lambda minus t. Take t is equal to 0. When you differentiate, you get first derivative will be this lambda into lambda minus t whole to the power minus 2. When you differentiate it again, you see that you get it to be 2 lambda divided by lambda minus t whole cube. Take t is equal to 0. So you get 2 lambda divided by lambda cube. That gives you 2 by lambda square. Now, having found the value of this e of x squared, substitute in its place. Sigma of x squared is equal to e of x squared minus e of x whole square. That's it. This is nothing but 2 by lambda square minus e of x is equal to 1 by lambda, therefore 1 by lambda square. Now, subtract it, you get sigma of x squared is equal to 1 by lambda square. So, this is the variance of the exponential distribution, and this is the mean of this. And even if you do like this, you will get the same value you will get. Okay, this is about the expectation and the variance of the random variable that follows an exponential distribution. Now let me today prove the Memoryless property of the exponential distribution as well as the geometric distribution. See, exponential, what it tells you is that what is Memoryless property of this? If you are going to mathematically write it, this is given by p of x greater than s plus t slash, this is a conditional probability, slash x greater than t is equal to p of x greater than s. Here I am taking x is a random variable that follows exponential distribution. See how we define this Memoryless property. Memoryless property of this exponential states that the probability that an event will occur after certain time t plus s. See, after sign, this is a random variable that talks about the time of happening of certain event. That should happen after s plus t, given that the event has not occurred by the time t. It has not occurred by the time t, but we are trying to find out the probability of the event to happen after t plus s time. That is p of x greater than s plus t, given that it has not happened till t is as good as finding the probability of the event to happen after the time s. So that is what it is stated. It states that the probability that an event will occur after a certain time t plus s, after sign t plus s, given that it has not occurred up to time, by the time it has not occurred t, is same as finding the probability of this conditional probability is same as finding the probability of this x greater than s. So this is what we are going to prove, and there is no memory. You just find out what has happened before. It is not required. That is why it is called a Memoryless property. Now let us prove this. Before that, this is called your conditional. This is called a cumulative distribution function. This is called the cumulative distribution function. I will write it. This is your cumulative distribution function. This is the cumulative distribution function. It is given by p of x less than or equal to x. This is equal to fx of this 0 to x. If this is integrated, you will get e to the. So it's a very simple integration. You go for this into lambda can be taken outside. Do the integration. E to the power of 0 will be 1. So you get this 1 minus e to the power of minus n. So this is the cumulative distribution function. When therefore p of x greater than x will be equal to 1 minus p of x less than or equal to x. That is 1 minus this value has already been formed. So it is you subtract and you get that 1 minus 1 will go giving you e to the power of minus lambda x. Therefore p of x greater than x will be equal to e to the power of minus lambda x. So this is for what? The exponential distribution. This is the truth. Okay, now let us come to this here. Now let us come to this. What is this? This is nothing but a conditional probability. we know that, see right here, we know that P of A slash B is equal to P of A intersection B divided by B, provided B of P is not equal to 0. So this is a conditional probability. So writing in this way, you see that x greater than s plus t intersection x greater than t divided by x greater than t. Here you see that the intersection of this is nothing but your p of x greater than s plus t, greater than s plus t, because up to this t and this is more than t, s plus t is more than that. So if a common this thing is p of x greater than s plus t divided by p of x greater than t. This is p of x greater than t. Now what is this? Now as per this we have done. See, p of x greater than x is nothing but what? E to the power of minus lambda of x. So in the place of x you have got s plus t. Therefore minus e to the power of minus lambda in the bracket s plus t divided by, it is same as this. In the place of x you have got your t. Therefore e to the power of minus lambda t. So simplifying you get e to the power of minus st. But e to the power of minus st is nothing but what? It is p to the power of p probability of x greater than s. Therefore, what is that we find? The conditional probability of x greater than s plus t slash x greater than t is nothing but the probability of x greater than s. This is nothing but your memory. What has happened before s, it need not be known. That is a memoryless. It is not required. It is not there. So it is memoryless. And what is after that is required. That is probability of that is given. P of x greater than s. So this is about the probability, that is the memoryless property with regard to the exponential distribution. Now let us come to memoryless property of the geometric distribution. Now, so this property takes more than the probability, the process takes more than m plus 1 trials, given that it has already taken more than m trials, is same as that it takes more than n trials. That means here you see that the probability that the process takes more than m plus 1 trials. See, if you want to get one success, let us suppose that m plus n trials are required to get a success. Given that already it has taken m trials to get the first success. Already m trials have taken place to get the first success. But the process has taken more than m plus n trials now to get the first success. When in such cases, tries the same as the probability. So that probability, that conditional probability is same as probability of x greater than n. Now, what we should know is, here I have written something here. P of x greater than x is equal to q of x. Here x follows geometric distribution. This means that the trials more than x are required before getting the first success results in q to the power of x failures. So before this, if you want to get more than, if you are conducting more than x trials, then q to the power of x trials must be failures to get the first success. So that is the meaning of that. So here you see that p of x greater than m plus n is great slash x greater than m. This is a conditional probability as I have written here. So that is equal to p of x greater than m plus n intersection x over x greater than m divided by this. But this is nothing but q to the power of, this is nothing but your p to the power of, this is here I will write here. See, this is your p x greater than m plus n divided by p of x greater than m. That is equal to p of x greater than m is q to the power of m plus n divided by q to the power of m. That is equal to q to the power of n. That is equal to greater than m. So you see that this is nothing but p of x greater than m plus n divided by p of x greater than m. But p of x greater than m plus n, as per the logic here, this is nothing but what? Here q to the power of m plus n, and this is p x to x greater than m, p of x greater than m is q to the power of n. So your cancellation you get q to the power of n, which is nothing but your p of x greater than n. That is p of x greater than m plus n slash x greater than m is nothing but p of x greater